Hi everyone, my name's Sarah. I'm a postdoctoral scholar at UC Davis, and I'm delighted to present work co-authored with Professor Julian Alston, who's also at UC Davis. Wine is an incredibly differentiated agricultural product. There are around 5,000 wineries in California, and if we were to assume each winery produces around 10 labels and has 2 vintages for sale, that would mean there are around 100,000 wines on the market from California alone. There's a lot of differentiation that's based on the wine grape variety and the terroir, as well as features of the natural environment, things like the soil type and the climate. And wineries can have really different approaches to the winemaking process. And so compared to any other agricultural product, this introduces an incredible amount of variation in price. So here we've got 2 wines, the Screaming Eagle Cabernet Sauvignon for over $6,000, and compare that to a bottle of 2 buck chuck at Trader Joe's, although I think it's $3 now. Hasn't quite got the same ring to it, but as you can see, there's just an incredible difference in price between these 2 really different wines. It's also been long understood that there's vintage weather affects wine grape characteristics, things like the color and the acid, and that can introduce vintage to vintage quality differences in the final wine. Now, this is an oversimplified representation, actually says in top corner, blatantly oversimplified. But this does demonstrate the point I'm trying to make, and that's that vintage differences across these wine grape growing regions can result in different wine quality for those vintages. And as a consequence, there are a lot of variation in the prices of wines and the grapes used to produce it, not just within the same variety, in the same vintage, in the same region, but also temporally across years. Even if you condition on the same vineyard and same winemaker, you can see really different prices for that wine. This variation in quality and prices led to an asymmetric information or lemons problem that's really pervasive in the market for fine wine. And 100 years ago in France, this led to the introduction of geographic indicators. The purpose of associating a wine with a GI or geographic indicator, and that's to leverage the collective reputation of the region and help generate price premia for the winemakers. And around the world, there's been this nexus that has developed between wine grape varieties and places of production as signaled by these geographic indicators, which is fundamentally driven by aspects of that GI, things like the climate and other aspects of terroir. So Barossa Valley Shiraz is an example from Australia, which is where I'm from, or more relevant for my presentation today is the Napa Valley is really well known for Cabernet Sauvignon. So in this study, we ask how climate change may disrupt the established structure of private and collective reputation associated with geographic indicators. Today, I'll present some preliminary results that start to unpack this interesting question. Our work uses 2 key data sets on premium varietal wines from California. First, we collect wine ratings and recommended retail prices from Wine Spectator magazine from 1994 through to 2022. We supplement this with actual prices paid by buyers of ultra-premium wines through auctions that are hosted by K&L on K&L Merchant House. This is a wine auction house. We match that to spatially detailed weather data from PRISM to best represent the regional weather and climate that affected the wine grapes during the vintage. So setting more broadly is California's 3.6 billion wine grape industry, which is the second most valuable crop in California after almonds. California produces around 80% of US wine in several distinct production regions. So there is the cooler Central Coast and more coastal regions more broadly that are known for Cabernet Sauvignon and Pinot Noir, more cool climate varieties. And then within the North Coast, a bit further inland, is the Napa Valley, which is better known for Cabernet Sauvignon. Now, as I think everyone in this room knows, American winemakers can associate with AVAs, or American Viticulture Area labels. They were introduced in the 1980s, and that's a kind of geographic indicator for wine producers, which you can associate your wine with so long as a large proportion of the grapes were grown in that AVA and the wine is fully finished within California. These AVAs can be large. The North Coast is an AVA, but they can be small and lie wholly within another AVA. So here we have the Napa Valley and then sub-AVAs within like Oakville. Okay, I'll talk a bit more about the data. We have wine observations from Wine Spectator magazine, who blind review 15,000 wines or so every year. For each wine, we record its winery, the region, vintage year, the rating, the suggested retail price, the number of cases made, and also the wine grape variety. We collect prices from K&L Wine Merchants. It's an auction house based in California that brings together independent buyers and sellers of fine wine. Unlike Wine Spectator magazine, that publishes a recommended retail price as declared by the winery, K&L prices are real sales of fine wine. Weather data we take from Prism. Prism interpolates daily minimum and maximum temperatures, as well as precipitation, to 800-meter grids, taking into account things like elevation, coastal proximity, and aspect. These weather data are daily by 800-meter grids, while our wine data is at the vintage and regional level. So matching these two data sets together is going to require both temporal and spatial aggregation. So on spatial aggregation, what we do is we identify every prism grid that lays within a wine region using the region boundaries from the AVA digitization project team. And then for each region, we take the weighted average of the weather variables across the grids that lay within it. And each grid's weight is equal to the share of the region's great acreage within that grid, as measured by the USDA's cropland data layer. So for example, if a prism grid wasn't associated with any grape acreage, it would be assigned a weight of 0 and it won't contribute to the weighted average. Temporal aggregation I'll speak to in a couple of slides. Before that, I want to show some summary statistics across the largest regions in our data set, and we're pooling together all varieties here. So looking at climate, that's just the average growing season temperature. You can see there's quite a bit of variation spatially there. The cooler regions like Sonoma is more coastal, and the warmer regions like Napa Valley. There's also considerable variation in price that's reflecting differences in wine quality and reputation. Now, there's also variation in the scores across regions, but overall the variation score is smaller than that of price. There's some interesting differences between the prices from Wine Spectator magazine and K&L. Overall, the Wine Spectator prices are much lower, and that's partially because these Wine Spectator prices are the recommended retail price when the wine is released, which is on average about 3 years after the wine's vintage. By comparison, these K&L prices are about 11 years after the wine's vintage. This is much closer to when the wine is ready to drink, and we have a better understanding of the quality of that bottle of wine at that point too. And overall, these are expensive wines, and on average for the K&L price, $126 on average. So we are focusing on a subset of wines that are premium or even ultra premium wines. Okay, so going back to our approach to temporally aggregate temperatures. So here we're showing daily temperatures with the maximum temperature shown in red and the minimum temperature in blue across 1 month in one region. What we do is we fit a sine curve in between each day's minimum and maximum temperature. You can then integrate under the curve and sum across the days to estimate how much time is spent in a given time temperature interval in a month. And that's a distribution in green on the right of this graph here. So previous work done by economists typically uses broad season averages. There's a famous quote: if you had 1 foot in a bucket of ice water and 1 foot in a bucket of boiling water, an economist would tell you that your feet are the perfect temperature on average. But what really matters for wine quality and prices is extended periods of extreme heat or extreme cool at particular times of the growing season. Now, average temperatures is going to potentially conceal quite large differences in exposure to extreme temperatures. So we're going to use this technique instead, which allows us to better capture exposure to those extreme temperatures. Here's an example just for 1 month. We do this for every month, for every vintage and for every region, which is shown on average here. So here we're showing the density in days is shown by the color, and we're averaging here across all regions and vintages, but when we're doing the modeling, we're going to match each wine observation to what this picture looks like for its corresponding region and vintage. Now, one could use all of these bins as independent variables in a model, which we do, but it yields some somewhat unintuitive results, which is likely a consequence of, like, this is some 200 independent variables trying to explain one observation of price. And there's a lot of correlation between neighboring intervals. So instead, what we're going to do is impose some structure using what we know about temperature's effect on fruit quality to better model this relationship. So what we do is we aggregate up to degree days over key temperature intervals and stages of the growing season. And our choices of interval cutoffs is motivated by work by people like Greg Jones and other experimental work done on wine grape quality. We focus a lot on exposure to hot temperatures, since this is where a lot of the action is, particularly for places like California, where it already is quite warm. So we understand that grape vines can withstand exposure to temperatures above 30 degrees Celsius for some periods. But once we get above 35 degrees, it's likely that is going to cause damaging heat stress. And after veraison, which happens in late July, grapes are believed to be quite vulnerable to the negative effects of heat. So we split up those hot temperatures into pre and post veraison. And for our results, we're going to focus on degree day variables relative to degree days from 10 to 30 degrees Celsius, which we're going to drop to serve as the comparison group. Okay, so here are the results for the natural log of wine prices using the K&L wine merchants data. Each column is showing results from a separate regression model, one where we pool all varieties together, and then there's one just for Cabernet Sauvignon and one for Chardonnay. The numbers are the marginal effect. It's the percentage change in price caused by a 1 standard deviation increase in the explanatory variables shown in the row. So for example, a 1 standard deviation increase in degree days above 35 degrees Celsius during August to October will cause prices to decline by 1.3% on average. Okay, so what these results show overall is that vines can mostly handle temperatures between 30 to 35 degrees Celsius before veraison, whereas post-veraison we find to be damaging. And above 35 degrees Celsius is pretty bad news pre and post-veraison. Now, it's pretty similar across the different varieties, and we also run subsamples of regions, and results we find to be broadly consistent. And just thinking about these results, it's important to recall that these are extremely valuable wines and that these results implicitly embed any adaptation within the vineyard and the winery that may have been taken. So despite all of these adjustments, we still find a significant impact of temperature. Okay, so here we're just looking at the Cabernet Sauvignon results for K&L prices and then the 3 main outcome variables from the Wine Spectator. So Wine Spectator prices, we find overall kind of like a similar pattern, but that the magnitude is smaller and overall there's very little statistical significance. So what we suspect is that the suggested retail price is stickier than a real price paid, and it's much less reflective of the vintage variation. And given it's a recommended retail price from the wine maker, and it is recorded so close to the vintage, 3 years on average. For scores, we do see significant effects, but the magnitudes are smaller than the magnitudes we find for the K&L prices. And I think in part that reflects the lower variance that we see in scores overall. We do see quite large effects on the number of cases made. Now, this could reflect a simple yield effect of weather, but it seems less likely in the case of fine wines where growers are actually managing yield, and mostly they're thinking about preventing yields from being too high to help maintain quality. So we actually think that this result more likely reflects winemakers choosing to produce smaller quantities of high quality brands during vintages where there was less favorable weather and lower quality grapes. Climate change is going to cause warming in many key wine grape regions around the world. In this table, we're showing for the Napa Valley AVA, we're showing 10-year averages, historical, and then projected out to mid-century and the end of the century. Average temperatures are around 18 degrees historically, and that's projected to increase to 22 degrees by the end of the century under a middle-of-the-road emissions scenario. But focusing on average temperature hides even larger expected increases in exposure to hot and very hot temperatures, as measured in our degree day variables here. So you can see it's actually expected to double the amount of time spent between 30 to 35 degrees Celsius. And above 35 is expected to increase by a factor of 4 or 5. Now, we can use these climate projections and the estimated effects of temperature to estimate the effect on wine prices in the future. But there's some important caveats here. These model parameters are calibrated to the technologies and strategies that are used during our period of analysis. So we're effectively assuming that there's no adaptation in the future. So we're assuming there's no adaptation of varieties, no adaptation of acreage, and we're also assuming everything else is equal, like all demand effects are equal, which are all somewhat naive assumptions. But with that caveat in mind, what our results imply is a decline of price of 41% by the end of the century, absent any additional adaptation and assuming everything else remains equal. And what really matters for wine quality and prices is not the average temperature throughout the growing season, but rather it's these extreme temperatures at particular times of the growing season, especially as high temperatures post-veraison. And an implication of our results is that producers will feel strong pressure to adapt their methods of production in the vineyard and also in the winery to help preserve quality and the premia associated with this production of the signature variety Cabernet Sauvignon in the Napa Valley. And those adaptation strategies is something that Julie and I are really interested in better understanding in future work. Thank you.